Hello everyone, I'm Baolong Mao from Tencent. My work at Tencent focuses on developing Apache Ozone, which is the next generation distributed object store, and aim to build a data lake by Ozone. I'm also a PMC member of Alluxio open source community, as well as a committer of Apache Ozone. Prior to Tencent, I worked for Alibaba and JD.com to build a big data distributed storage system by HDFS and Alluxio. Now, let's talk about how to integrate a storage system as a new under-file system of Alluxio. First of all, I'd like to share some of the contributions from my team at Tencent have made to Alluxio. Recently, we pushed Ozone and Cause N UFS into Alluxio repository to make it possible to access Ozone and Cause through Alluxio. Another important feature is that we pushed a new commit so that it can support using IP as connect host. Without this feature, sometimes we access Alluxio from Presto and find that the Alluxio worker hostname is different from Alluxio worker and Presto, so the locality is bad. It can be worse when Alluxio client don't know the hostname of a worker. It can make the connection fail. I believe that lots of companies have its access control system. Before our patch, Alluxio permission checker has only one default implementation. With this feature, you can implement your permission checker by yourself. As a better monitor system can help to mirror and tuning the performance of Alluxio cluster. So we spent some time to share a generic dashboard template and a related document to lead you from zero to a wonderful monitor system for Alluxio. As there are lots of contributions, I won't go over one by one right now. So let's return to this talk now. In this talk, I will share my experience in developing Apache Ozone and the file system of Alluxio, showing how to create a new under-file system in a few steps with minimal lines of code. This talk will focus on how the unified namespace works in Alluxio with different under-file systems, and how to create a new under-file system to connect to Apache Ozone. Then introduce the Alluxio under-file system framework. Finally, demonstrate how to use Ozone in Alluxio. First, let's take a look at how Alluxio unified different UFS into a global namespace. This diagram gives you an idea of how it works. Here you can see that we can mount many popular storage systems to Alluxio, and these popular applications can access Alluxio without any code changes. In fact, Alluxio is the data orchestration for analytics and AI. In Alluxio, an under-file system is the plug-in to connect to any file system or object stores, so users can mount different storage like AWS S3 or HDFS into Alluxio namespace. This under-file system is designed to be modular in order to enable users to easily extend this framework with their own under-file system implementation and connect to a new or customized storage system. Now we can mount HDFS, S3, OSS, COS, and Ozone together to Alluxio. In a sense, Alluxio is a global mount table, maintain a global centralized mount table, and supply a global namespace. We can mount lots of under storage into Alluxio. The end user don't aware where the access operation mapping to, which storage system is being accessed. Even we remount a mount point from one storage to another storage. Client and end user need to do nothing. As Alluxio getting more and more popular, as Ozone wasn't the UFS of Alluxio yet. So I did some minor effort to make it possible to access Ozone through Alluxio. Now, let's take a quick look at Apache Ozone. In a word, Ozone aimed to become the next generation distributed storage, an approach of data lake. Many applications can access Ozone through various API. Leverage Hadoop-compatible file system interface. Ozone can be used for big data ecosystem. Leverage CSI S3. Ozone can serve as cloud storage. And the leverage Alluxio. Many applications can access Ozone easily. Meanwhile, Alluxio can supply a tiered cache service, which can speed up the access performance. These small rectangles in the big green rectangle is the core rows of Ozone. We call it Hadoop distributed data storage. It is a common storage layer. The dark green rectangle SCM is the storage container manager. It maintains the block container and the data nodes. The HDDS data node services are responsible for store block data and supply data stream service. The yellow rectangle OM is the Ozone manager. It is an object store met service, responsible for maintaining the object metadata, something like volume, bucket, and key metadata. All the Ozone client will talk to OM and data node to write or read object data, but don't communicate to SCM directly. Before introduce how to integrate Apache Ozone as an underfile system of Alluxio, let's understand the Alluxio UFS framework. Know how Alluxio UFS works. So, how to mount an underfile system to Alluxio? Just a simple command line, like the given example. The /ozone is a mount point in the Alluxio namespace. The following parameter O3fs:// is an Ozone address. As Alluxio accesses Ozone by Ozone file system, which is an implementation of HCFS. So we should specify the necessary configuration file which contains the Ozone cluster's address and specify config items. There are so many underfile systems in Alluxio now. So how Alluxio discovers the supported UFS? Firstly, extension jars are loaded dynamically at runtime by Alluxio servers, which enable Alluxio to talk to a new underfile systems without requiring a restart. Secondly, Alluxio servers use Java Service Loader to discover implementations of the under-storage API. Providers include implementations of the under-file system factory interface. Finally, the implementers need to create a file under file system factory to point specific under file system factory. One more thing is, implementers are required to include transitive dependencies in their intention jars. We usually call it fat jar. Alluxio performs isolated class loading for each intention jars to avoid dependency conflicts between Alluxio servers and intentions. Each jar of underfile system module will appear in the lib directory after build. Then, service loader will discover this underfile system from these jars. The left picture is the submodule of underfs. The right picture shows the generated jars of underfile system from the modules by Maven package. Well, how to implement an underfile system? First, you should implement the underfile system interface. Choose a better appropriate parent class to intents can reduce lots of your effort. It is not very difficult. There are only few of methods you have to implement, like the right picture. And you should create a text file in the specific path and fill your underfile system factory class name here. To get a fat package from Maven package, you also need to add the two useful Maven plugins to your module to build an individual jar with dependencies. In fact, now Ozone can be an underfile system of Alluxio already, after merged my pull request, so that we can mount Ozone to Alluxio. The Alluxio client can access Ozone through Alluxio master and worker. The most important motivation to do this work is that Alluxio can keep the file system semantic metadata for Ozone. It can speed up the file system semantic operation like list status. The list status is an expensive operation for object store, but for file system, it is easy and fast. Also, Alluxio can catch the date for Ozone, so I think Alluxio can speed up Ozone for big data workload. This is the Ozone UFS supporting related change list. The most important one is Ozone underfile system factory. It intends HDFS underfile system factory so that it can reduce writing lots of code. The key point is I use Ozone file system to access Ozone, and Ozone file system is an implementation of Hadoop compatible file system interface. Lots of work is done by HDFS under file system factory. Even I don't need to write an Ozone under file system at all, because HDFS under file system is enough. One detail I should clarify is that I have to create an extra shade Ozone module as a dependency of underfs Ozone, because underfs Ozone module dependent underfs HDFS module. So many dependency classes have been shaded by HDFS shade module. If I don't shade Ozone, it will meet class case exception. But if you are writing a new UFS module fully without dependent any existing UFS module, you don't have to worry about this problem. The screenshot below is the file which service loader requests. The content is the Ozone under file system factory class name. Alluxio discover the Ozone UFS by this. The footer link is the PR about making Ozone as a UFS of Alluxio. If you want to know more about how Alluxio can access Ozone, you can get all affected files by this PR. Maybe not everyone is familiar with HCFS, so let me briefly cover it here. It is an API of file system. Its original purpose is for HDFS, but HDFS getting more and more popular. Many storage file systems implemented the HCFS interface, so that the application of Hadoop ecosystem can access this storage system without code changes. The HCFS framework can find the related file system implementation through the schema. Actually, HCFS become a standard API of Hadoop ecosystem. For example, the file system of HDFS is distributed file system. The file system of O3FS is Ozone file system. The Alluxio master web UI shows that we mount an Ozone under file system. We can list the children of an Ozone directly. We can also read a file content from Ozone by Alluxio. Alluxio command line tools can also list a directory and get a file content from Ozone. You can find all of these resources in Alluxio's documentation, which is very well written and helpful from my experience. These are several ways to join Alluxio community: Slack, DingDing group, WeChat group. I'm active on all of them with other Alluxio core maintainers and PMC members. If you'd like to join Ozone community, please connect with me via WeChat or email. Thank you.